Have you ever just looked up at the sky, seen a massive airplane soaring by, and then maybe a tiny little bird, and wondered, how in the world do they both manage to stay up there? Well, today, we're going to pull back the curtain on the incredible, invisible science that connects them. It's a fantastic story of powerful forces and really ingenious design, both in nature and in our own amazing machines. At first glance, a delicate little bird and a giant metal jet, these seem like total opposites, right? One flaps, the other roars with engines. But here's the thing. They are both playing by the exact same set of rules, these invisible laws of physics, to conquer the air and fly. Okay, so let's dive right in. To really get a handle on flight, we first have to understand the four basic forces that are always at work on anything that's in the air. You can think of it like a constant, invisible tug of war happening up in the sky. First up, we've got the absolute star of the show, lift. This is that magical upward push, the force that seems to just defy gravity and get something off the ground. Seriously, without lift, nothing is going anywhere. And of course, battling directly against lift, you've got weight. This one's pretty simple, right? It's just gravity, constantly pulling down, trying to bring everything back to Earth. So you're up, but you need to actually go somewhere. That is where thrust comes in. This is the power, the push, the forward force from engines or flapping wings that propels an object through the air. And finally, pushing back against all that forward motion, you have drag. The easiest way to think about drag is like air friction. As you move forward, the air itself pushes back, always trying to slow you down. So here is the absolute key to the whole thing. Flight is a balancing act. For a plane to take off or a bird to soar, the forces for flight have to win that tug of war. Your lift has to be stronger than your weight, and your thrust has to be stronger than your drag. It's this beautiful, constant dance between these four forces. Which, of course, leads to the big question. How do flying things actually create that all-important lift? Well, the secret? It's not some crazy technology. It's hidden in the very specific shape of a wing. And that special shape has a name. It's called an airfoil. If you look really closely at an airplane wing or even a bird's wing, you'll see it. It's got that classic curved shape on the top, and it's much flatter on the bottom. Now, that design is absolutely not an accident. It is a masterclass in bending the air to your will. So, how does this simple shape work its magic? It is just brilliant. As the wing slices through the air splits. Because of that curved top, the air going over the top has to travel a longer distance, so it has to move faster to meet up with the air below it. And here's the cool physics trick. Faster moving air has lower pressure. So you end up with low pressure on top of the wing and higher pressure below it. And that difference in pressure literally pushes the wing up. That's it. That's lift. And that right there is the secret sauce. It's not magic at all. It's just pure physics. A simple difference in air pressure, but when you spread it out across the huge wings of a jumbo jet, it is powerful enough to lift a 400-ton machine miles into the sky. I mean, how amazing is that? Okay, so let's put this into practice and see how it all comes together in something we all know, an airplane. A machine that was designed from the ground up to master these very forces. In an airplane, the jobs are split up really clearly. You've got the huge wings with that perfect airfoil shape, and their main job is just one thing, create lift. All that forward motion, the thrust, well, that's handled by the super powerful engines, or the propellers. And get this is what's so cool about that airfoil shape. A propeller blade, it's basically just a tiny little wing that's spinning vertically. But instead of creating upward lift, it's tilted just right so that it creates a forward force, which is thrust. It's the exact same principle, just pointed in a different direction. But, as clever as our engineering gets, nature is often way more efficient. So let's take a look at how our feathered friends deal with the exact same problems of flight. Now this is where birds are just unbelievable. Unlike a plane with its different specialized parts, a bird doesn't have a separate engine. Its wing is like this all-in-one, incredible multi-tool that has to generate both the upward lift and the forward thrust. So how on earth does it do that? Well, it has a wing that's brilliantly divided into two parts that do two different jobs. The inner part of the wing, the forearm, stays pretty still and acts just like an airplane wing, giving it stable lift. But the outer part of the wing, kind of like its hand, flaps and moves a lot, acting like a propeller to create that crucial forward thrust.
And this quote from the source material for our explainer just nails it. As the bird flaps, it's not just pushing air down, it actually twists the hand to produce a forward force. It's this incredibly complex and elegant twisting motion that our propellers can really only imitate.
All right, let's bring it all home. We've got these two totally different flying machines, one made of flesh and bone, the other of metal and wires, and they're both solving the exact same physics problem.
So you can really see the two different game plans here. The airplane uses specialization, one part for lift, a totally different part for thrust. The bird, though, uses integration, one incredible, adaptable tool that does both jobs at once. It's a fantastic example of two different paths, one biological, one technological, both arriving at the same incredible goal: flight.
So why does all this matter? Well, because these basic rules are universal. By understanding how a simple airfoil works, and by studying the amazing solutions that nature has come up with, our engineers can design and innovate everything, from the next generation of super-fast jets to those tiny, silent drones we're starting to see everywhere.
And that kind of leaves us with one last thing to think about. That airfoil principle is all about using a special shape to control how a fluid, like air, moves. So where else do we see it? Think about the spoiler on a race car, pushing it down, or the giant blades of a windmill, or even the sails on a boat. Once you start looking for it, you'll realize the secrets of flight are truly all around us.